Since I only have 5 minutes, I'll get right into it. So the title of my presentation is Geological Mapping, Regional Geological Mapping and Data Collection with the use of Remote Sensing and QGIS, a case study of Kiunga-1 250,000 mapping, which my colleague has already introduced the location. So this is the outline I'll go by. So since pre-independence, 1975, a total of over 5 map sheets in the southern plains of Papua New Guinea were not completed. And under MRA's corporate plan, they've planned to cover these data gaps. And Kiunga-1 250,000 is the first map sheet that the project that we are undergoing at the moment. So the pre-field map was generated through using a lot of remote sensing data, and these are the following data sets that we used: SAR, Sentinel-2, Landsat 7 and 8, and DM, manipulating hillshade and relief for structural interpretations. So in PNG, where vegetation cover is an issue, radar assists in geological mapping. So the L band and the P band, as you know, penetrates vegetation to the forest floor, allowing for topographical features to stand out. So radar coupled with DM exposes the highs and lows of landforms, assisting in lithological and structural interpretations. The pre-field geology map was extrapolated from existing adjacent map sheets using as well as petroleum well data, geophysics, historical data, and publicly open source available remote sensing data, as I mentioned. So structural mapping was done using shaded relief mostly. So through the technique of hillshade, where you manipulate the light angle and you play around with that to generate different types of images. So that's what it was done, and these maps just show different angles of light. And this is where structural interpretations were made. Vegetation mapping was done using Landsat 8, so swamps and wetlands are better defined with false color images that shows boundaries of swampy areas and dry land. So this is the outcome of the geological map sheet that we generated. It's just desktop map, yes, before going out to the field. So remote sensing aids in geological interpretations, but fieldwork is always important for factual confirmation of interpretations. The work of a geologist to work the earth continues. So this is some of our field confirmations of different rock types that we did in the office. We had to go out to the field and confirm with geological mapping. So QField was utilized in 2 main ways. So I found it useful in aerial mapping as well as data collection while on the ground. So for QField was used to easily identify target areas in aerial survey. The live location assisted in directing the pilot to fly over target areas for aerial mapping and to check for possible landing sites. As you know, PNG is heavily vegetated. Vector files of the pre-field geological map were placed in a geopackage file and viewed in real time with moving locations seen in the air. This added confidence to interpretations made in the pre-field map, and in addition, aerial mapping was done in real time of features observed. Example shown here shows an interpreted map that was a screenshot of on my phone, and an aerial image with a change in lithology that confirms the lithological boundary. So this just shows the attribute table of what we collected in the field and then easily transferring it to QGIS. So QField allows for ease of geological data capture and significantly reduces the need for having to type your field notes, as it is already in a GIS editable format and can be easily manipulated. And this just shows some of the data that we captured out in the field and playing around with it in QGIS. As a geologist, I feel like taking field notes and drawing sketches complements QField. It doesn't really completely get rid of it. To conclude, remote sensing data like SAR, Sentinel, and Landsat used in lithological and structural interpretations in densely vegetated areas like PNG are applicable to some extent. Field geological data collection consolidates desktop interpretations and goes to show geological fieldwork and factual data are still significant. QField allows for use of geological data capture and significantly reduces the need for having to type your field notes. Challenges: time was a factor in mapping the QField. The more time you had, the information could be added in each and every field. And QField data entry becomes more of a build a column type activity and could possibly limit rethinking in terms of geological observations. Recommendation: it is, I won't talk about the first one, but just the second point. It is recommended to use QField in conjunction with taking field notes. A good old geological sketch in the field provides a lot of useful data, and in the case you lose your electronic device, your field notes are your backup. That's all. Thank you. Remember to have fun while working.